This is a video about thrust and journal bearings and why they're used in engineering applications. I'm going to draw from my background experience working as an automotive technician for 10 years, as well as the information that I've learned while researching thrust and journal bearings through my engineering education. For the two types of bearings, they have a little bit of difference for the forces that act on them. So for journal bearings, it has two forces that are acting basically perpendicular to the axis of the rod. And they also have two moments in those directions as well. There's no force and no moment along the actual axis of the rod. So in the picture, you could see in the y direction, there's no force or moment in those directions. So that's where the difference between a journal bearing and a thrust bearing comes in, because the thrust bearing has all those forces and moments, but it also has a force along the direction of the axis of the rod. So you can see where it shows Ry that there's a force pushing along the y-axis. Engineers use bearings anytime there's a rod or a component that is rotating about an axis. The bearing offers support as well as protection from increased friction and wear. Believe it or not, bearings can fail. It's actually quite common depending on the application. The picture that's on the right there is a picture of engine crankshaft main bearings. These bearings, you could tell originally they're supposed to be pretty symmetrical. They're supposed to be smooth, no divots or anything like that in there. And you can see that these bearings are pretty damaged. Typically, damage like this would happen from either debris or dirt getting into in between the bearing and the crankshaft, or it could also, like the main cause would be it running out of oil. So lack of lubrication makes more friction that causes more heat, and then the metal ends up melting. So bearings are typically made out of a softer material than what the crankshaft would be made out of, and this is true in most applications. Because we want the bearings to fail before we want the actual main component to fail. Because bearings are fairly cheap. A set of bearings you could probably get for $60, $70 from a dealership versus a crankshaft would be maybe 12, $1,300. So they try to prioritize failing the bearings versus failing the actual crankshaft itself. Here's another example of a bearing that failed. This is a bearing it's a wheel bearing out of a car. And you can see it's a roller bearing setup. As you can see, a lot of these rollers have pitting, and there's also damage to a few of them, which means that this bearing needs to be replaced. So typically when somebody's driving their car, if they have a bad wheel bearing, you'll either feel a vibration or there might be a clunking noise. And there's also going to be a relatively loud growling noise. That growling noise is due to this pitting and damage and things not operating properly. Another symptom of a bad wheel bearing is that when you grab the wheel, like the actual wheel itself, and turn it side to side, you might actually have excess play, which is quite dangerous because if that wheel bearing completely fails, it could be somewhat of a catastrophic failure, and you might lose control of the car. So it's definitely something to keep an eye out for. So as you saw in the last two slides, there's obviously a bunch of different types of bearings. So there's needle bearings, which is what the picture is all the way on the right there. You can see all the different little needles on the inside. It's pretty similar to like what a roller bearing setup is, but these are very small, skinny needles. I often see these in like differentials and stuff like that. Let's see, there's roller bearings, which is what we saw on the previous slide, as well as the bottom right there is an exploded view of a roller bearing. There's ball bearings, which we saw on a few slides up. It's basically the same thing as like rollers, but it has little spheres on the inside of metal that are held in a cage as well. Fluid bearings, which is what's here on the left. I don't really have too much experience with fluid bearings, so I'd have to look into that more. There's magnetic bearings, which has to do with using magnetic fields, and there's also fixed bearings, which is like a brass insert put into something that allows for less friction. So needle, roller, and ball bearings typically have an inner race and an outer race and a cage that holds the bearings, which is, as you can see in the picture on the bottom here, we have the rollers, the cage, and then I guess the cup on this would be considered kind of like the race for that. They also typically have like a dust or a grease shield. One important part of bearings is that they need to be lubricated. If they're not lubricated, then they produce a lot of friction, which can cause a lot of problems and premature failure. This is another example of a bearing. This is a roller bearing. It's another type of wheel bearing like the one that we showed before that was failing. So as you can see, the outer race is that large ring that's to the left. So the wheel bearing actually sits inside of that. So that would be mounted inside of like a steering knuckle or something like that. And then the cage that holds the rollers is basically in between the inner race and the outer race. And then you would have your axle would go through the inner race. So like I said before, failure of this bearing typically causes excess play in the wheel assembly, noise, and potentially a vibration. So here's a example of a thrust bearing, which we haven't really talked about too much. So this is a picture inside of an engine block. So as you can see, there's the spots for the pistons kind of towards the bottom of the picture. The arrow is pointing towards the thrust bearing itself. And then if you look a little bit towards the more top part of the picture, like right next to the thrust bearing, that's the main bearings that we saw in our previous picture. So that's what they're supposed to look like versus the previous picture that we saw that was pretty damaged. So in the automotive industry, they use thrust bearings on the main bearing in the center right here for the crankshaft. So what this thrust bearing does is it takes up any slack that's going to be in the actual crankshaft and the journal bearings. So there's always going to be some sort of play that's allowed to be in there. There's a specification on how much play is allowed. And you use these thrust bearings. There's going to be one on this side of this bar, and there's also one on the other side. And basically what the thrust bearings do is they take up that extra slack. So once you install these bearings, obviously the bearing allows for rotation, so it's going to allow for minimum friction. As you can see, the small little lines that are kind of towards the center of it, those are allowed for oil to seep through so that it can be maintained, proper lubrication and everything else. But it's necessary to have these in there to take away the slack that's in there, because if there's any slack, then it's going to cause things to wear out prematurely, and you could end up needing to replace a crankshaft or even an engine block because things are moving when they shouldn't be. So this is a continuation of the previous slide. The technician installed the crankshaft and the main rod bearings and bearing caps. As you can see on the left-hand side, the shiny part, that is a journal on the crankshaft. That is where the connecting rod and piston would attach to the crankshaft. In case you're unfamiliar with how car engines work, the journal bearings are connected to connecting rods and connected to the piston, and the piston is what's responsible for combustion inside your engine. So as you can see on the right-hand side, he has a dial indicator. That's that gauge right there set up against the snout of the crankshaft. And in the upper portion of the picture, you can see kind of like a silver bar, and that bar is either like a screwdriver or a pry bar, and he is prying on the crankshaft to check the amount of end play. There's a certain specification on how much end play there's allowed to be, and the dial indicator will tell that based on how he has it set up. If the dial indicator indicates that it's too high outside of specification, then that means that the thrust bearing is not thick enough, and he would need a thicker bearing. If it's too small, that means that the thrust bearing is too thick and he would need a thinner one. By not having a thrust bearing in there that meets the specifications, you risk causing too much heat, or there's going to be too much end play, and you could cause things to wear out unevenly. So this is my presentation on thrust bearings and different types of bearings, journal bearings, and I hope you guys enjoyed it. I tried to draw from some of my previous